Now with the continuation, we have to see what are all the types of perceptron. So the first, there are two types of the perceptron. The first type of the perceptron is called the single layer perceptron, and the second type of that perceptron is called multi-layer perceptron. So the single layer perceptron can learn only the linearly separable patterns. That means already we know what is the concepts of that linearity. So the linearity means the linearity between one dependent component and to the one independent component. So if the single layer perceptron is also working on that same linearly pattern, but it should have that separable patterns. We can able to differentiate the dependent and then so independent component into the linear parameter. And our next one type is called multi-layer perceptrons or feed-forward neural networks. So this kind of multi-layer perceptrons have two or more layers and that having greater processing power. In a single layer perceptron, we are having that only one varieties of layer. So one layer means we are having set of that inputs and set of the weights and then summation component, that means the hidden layer, and that has been output function that has been produced. But in multi-layer perceptrons or that feed-forward neural networks, we are having two or more layers that's having the greater processing power. So the perceptron algorithm learns the weights for the input signals in order to draw a linear decision boundary. So this enables you to distinguish between the two linearly separable classes. That means from +1 and -1. So already we said that the perceptron algorithm learns everything by that weights. How? That actual neurons are working according to that weights that's received from that its previous neuron. In same way, in that perceptron also we have to compute the weights along with that input signal in order to define the boundary of that linear decision boundary. So this one gives that two linearly separable classes. It's having in that +1 component, that means that's in positive component, and another one is called that is that negative components. And now we have to see the perceptron learning. So the decision boundaries or hyperplanes and learning as the process of shifting around, that is that hyperplane. Already we studied that what is that hyperplane in support vector machine also. So in that hyperplane, it's giving that exact classification of that positive boundary and then negative boundary. So in order to adjust this positive boundary and the negative boundary, we have to go with that support vectors, or that is support margins with that +d distance and -d distance. So in that same way, in that perceptron also, we have to make that a training pattern to be classified in boundaries correctly. And to formalize this process, we have to go with that shifting around into the systematic algorithm that can easily implemented. So the shifted around means it can split it into that numbers of that small steps. So now we have to see if the network waits at a time t is wij of t, then the shifting process corresponds to that moving them by the small amount of exclusive or of wij of t, so that at the time t +1 we have the divides. So in general we have to write this equation as like that of wij of t +1 equal to wij of t plus exclusive of wij of t. So this is that simple formula. So it is convenient to treat the thresholds as the weights as I discussed previously, so we don't have to need the separate equations for them. So this way the perceptron learning that has been taken place. And what is that perceptron's learning rule? So it states that that algorithm would automatically learn that optimal weight coefficients. The input features are then multiplied with these weights to determine if a neuron fires or not. And also the perceptron receives that multiple input signals and sum of that input signals and exits if there is any certain threshold. It either outputs a signal or it does not return an output. So in the context of the supervised learning and the classification, this can then be used to predict that class of the sample. So in this perceptron rule, we can able to see in that diagram, we are having that x number of that inputs and the w numbers of that weights, and that has been given for that net input function, and that has been derived to that activation function. If there is any errors that is occurred, that has been adjusted with the weights until we have to be reach out that appropriate output. Reason is we chose certain random weights along with that inputs. In order to make that output of the desired level, we have to readjust the weights that has been incorporated into the inputs of the neural networks. On that next we are going to see about that is the perceptron function.